Okay, hello everyone. Welcome to Lab 4 Electrical Drive. The name of this lab is three-phase variable frequency induction motor drive with constant voltage frequency ratio. In this part of the exercise, you will use the nominal voltage and frequency of three-phase induction motor to calculate the voltage frequency ratio to determine the characteristic of the motor. For sure, you know that the nominal voltage in Australia is 415 and the frequency is 50 hertz. The main thing you need to do for this lab, you need to change the PWM inverter frequency from 1/5 of nominal frequency up to 120 hertz. So we have done, this is the circuit as well. As you can see, the circuit is exactly the same as what we have done in lab 3 part C and D. There is three-phase full wave rectifier, three-phase inverter, and then we need to measure the voltage, face-to-face voltage, and the current as well. For that purpose, as you can see, the wiring is still same as the one we have done earlier. So we have not changed anything. The only change is just about the timing belt. So we back the timing belt here. All right. So now back to the setting here. We have set the chopper or inverter. Can you just we have set the function to three-phase PWM inverter for constant voltage frequency ratio, and we have set the knee peak voltage up to 117. And what we need to do, I have changed the frequency to 1/5 of nominal frequency, which is 10 hertz, and this is the knee frequency, or this is the nominal one. And then because we need to monitor the harmonic, the voltage in the harmonic, and also the current from the oscilloscope, so I try to show you all the details in one frame if I can do it here. Seems okay. What I need to do, I just run the IGBT from this point, and then we move to the output side. Okay. So because we start with 1/5 of nominal frequency, which is 10 hertz. So if you move to the speed here, can you move here? If you see this area, you can see the speed is below the nominal speed. Nominal speed for 50 hertz is about 1,500, but here you can see because now we set the frequency to 10 hertz. Of course, the speed is below the nominal speed. So now, if you move back here, from here you can see the line voltage at PWM inverter output, which is given here as 87 almost. And from the oscilloscope window, you can see the current as well. I have set channel 1 to current I1, which is the phase current. And as you can see, this is the RMS value. This is all parameters that you need to fill this table. Motor, for example, for our case, for the case the frequency is equal to 10 hertz, we found out that the speed is about 280 something, and the line voltage, as you can see here, is equal to 87 something, and the voltage RMS the current RMS value is about 0.25. From those two columns you can find the voltage frequency ratio, and at the end you are asked to plot the line voltage versus PWM inverter frequency. Based on those two columns, you can plot that curve. Just to show you what's the change here. For example, now I can change I stop this. What I need to do, I just change the frequency for the other one, for example 25. I do this same change here as well. Okay, I run this. Okay, as you can see, for once we set the frequency to 25, the speed increased up to 734. Yeah, it's 734. And then if you back to the oscilloscope and the current window here, you can see that's the value of the voltage, line voltage at PWM inverter output, which is E2, and also the current here is the value of the current is also given. Again, to save time, just to prevent overheating of the induction motor, I stop the lab at this point, but that's the procedure of this lab. Later on, I provide you with the full details. Okay, so here we have second part of lab number 4. In this part, we need to study the effect of constant voltage frequency ratio operation on the motor torque. In this part of the exercise, you will measure the torque produced by three-phase induction machine when the machine slip is nominal, and observe how it varies as a function of PWM inverter operating frequency. For that purpose, we need to change the PWM inverter frequency, same as the previous one. We start from 1/5 of nominal frequency, which is 10, and we need couple of data below the nominal frequency, and we need couple of more data for the case that we are above the nominal frequency. So that's why we need to start from 10 up to 100, and for that purpose you need to record motor synchronous speed and motor speed at nominal speed, and as you can see, the nominal slip speed for our case, I mean in Australia, is set up to 135. For that column, you need to minus the motor synchronous speed, but the nominal slip speed as well. And then for the other parameter, I'll show you how to find those parameters on the screen. Of course, you need to calculate the voltage frequency ratio. And let's see. Okay, so for this purpose, the wiring is exactly same as what we have done earlier, but in the setting previously, for the previous exercise, we have not turned on the constant torque brake, but in this case, because we need to study the effect of the changing the frequency on the torque as well, here we need to run the constant torque brake on dynamometer setting as well. So in that case, what I have done here, I have set the frequency to 10 hertz. That's the point we start with that point, and then of course the knee frequency is the nominal 150, and we can monitor the current in case you need it, and the voltage from the harmonic analyzer here. And you can also, in the same time, you can monitor the speed as well. Alright, so what I do, first of all, I run the IGBT from this part, and in the same time I start constant torque brake as well. So constant refresh. Here you can see the speed for our case, in case that the frequency is set to 10. So the speed is almost equal to this value, 287, and also this is the current in case you want to have an idea about this, and this is, let me press the continuous refresh here, and this is the voltage, I mean the phase-to-phase voltage. So what I do next one, just I do one more example. I stop this, I stop this one as well. Now let's change the frequency to, for example, 30. Okay, I change this setting as well to 30. Now I do same thing, run. Okay, so now you can see we have increased the frequency, and this is the speed. This is synchronous speed, and here you can see the voltage, line to line, phase to phase voltage, to almost 268. So once I provide you with the data, you will see that the characteristic of the torque characteristic will be changed from below the nominal value and above the nominal value. That's it. Thank you.